Hello. Today we're going to talk about external DNS for Kubernetes. And so external DNS is really important because external DNS allows you to control, manipulate DNS records within Kubernetes. Why are DNS records important? It's really about ingressing traffic into the cluster or multiple clusters, from within the cluster. So the Kubernetes administrator can create or manipulate DNS records to forward traffic into a cluster or multiple clusters, specifically for fault tolerance, for high availability, for A/B testing, for traffic redistribution, etc. Or if the applications are exactly the same, but they're two different clusters, and maybe you want to upgrade from cluster A to cluster B, you want to be able to move your traffic. And so external DNS allows the control of DNS records dynamically via Kubernetes CRDs. And so as you can see in this diagram, we have the BIG IP, and the BIG IP has the BIG IP DNS functionality on it. This specific example, and this is one of many examples, in this example, DNS and LTM are running on the same BIG IP, but it's a multi-NIC interface, right? The next example, I'm going to separate BIG IP LTM and BIG IP DNS. I'm just using one cluster, but I'm going to create multiple videos with multiple clusters. So this is just a single Kubernetes cluster that's running Kubernetes 1.19. But you're going to see in up-and-coming videos, I'm going to move this out to do multiple clusters for multiple examples. But before we get there, let's just kind of go through the fundamentals, go through the basics, and that's kind of where we are right now. So this user guide that you see here in this video, it's going to document F5 CIS and F5 CIS working with BIG IP LTM and DNS, right? And it's on the same device with a single cluster. So as you can see here, CIS actually has an API to communicate and plumb or articulate all of the CRDs created by the DevOps user. And we're going to do that. We're going to create a CRD, and CIS will populate that on LTM. Then we're going to create an eDNS CRD, and CIS will populate and create the wide IP. That's the external DNS, the external IP, the wide IP that would allow you to load balance between multiple clusters at the DNS level. So this is about what A record would you prefer. Is it A record cluster A? Is it A record cluster B? In my case, I'm only going to have one A record for one specific domain name or one specific namespace. In my case here, I'm working with a domain name called mysite.f5demo.com, and there are a couple others that I'm using. So let's take a look at what do we need to get this working. You need the requirements, the Kubernetes cluster, of course. It doesn't really matter what version it is. However, I'd recommend one of the latest versions, 119, 118 and above. We need CIS 2.6, which is coming out in October 2021. But you can use this image in the CIS deployment. There are CIS documentation, and of course you need a licensed GTM or a licensed DNS device on your BIG IP. So the first thing that you would have to do is deploy your CIS. And so you would deploy your CIS in Kubernetes through a Kubernetes manifest, which is a CIS YAML file. And in this instance here, what's different than before is that you're going to have GTM arguments. Now, as you can see, my GTM arguments are the same as my BIG IP arguments, so I can use the same BIG IP username secret that I created down here. kubectl create secret generic BIG IP login. And that BIG IP login is basically inside the service account, and in the cluster role binding, that's where I'm going to set those user creds, right? There are a few different ways that you can do this. This is the easiest of easiest ways. You can also load this in from a file. I totally understand that. In this instance, because GTM and LTM are on the same device, it's much easier. But if your GTM was on a different device, it would have a different IP here and potentially a different username or different variables here. This is well documented in the Cloud Docs documentation for CIS. So it's nothing new here within this user guide, but I've just provided the example. And again, this manifest is in the repo that you can clone. So these are the commands that I run. I am using Flannel or VXLAN. That's my overlay. So that's my VXLAN tunnel between Big IP and the Kubernetes cluster. So therefore, I'm using this dummy node as part of the OVN implementation. There is the CIS configuration. You can pull that down. That has this custom image pre 2.6 release if you want to test this in the next couple of days. So once you've deployed CIS and CIS is running, you could actually take a look at CIS. You can log CIS to determine if it's running or not. The next thing that you would need to do is you would need to deploy your demo app. So I have this demo app, and I've deployed this demo app in service. So this is the endpoint. This is really important because CIS is subscribing to that endpoint. And let's take a look. We can see kubectl get pods. If I can spell correctly here. And you can see there are my 2 pods, just very simple pods. These 2 pods are running. These 2 pods are deployed in Kubernetes already, and they're both running. And Kubernetes is also running in a different namespace here. System, you can see it right here. It's been running for 5 hours. So and I can log this, which is what I'm doing in here. I'm actually logging the API. So now that the app is running, we go to the next step. And the next step is to create the virtual servers. So this is the virtual servers in both DNS as well as the virtual servers within the CRDs within Kubernetes. So a couple of things that are important. When we're using eDNS, working in conjunction with DNS, we have to do a few things. We have to create a data center. So in DNS, so DNS data center, and I've created this data center called K8S19-cluster, and it's in the common path. And that's just a description. It's located in San Jose, California. This is the probe, and I don't really have any kind of fallback, so you can just use this is just really inside data center or generic. And these two are probe preferences. I just say inside, But that's the configuration. So if we go take a look at this DNS configuration, you can see the data center that is created. So here is the data center. You'll notice it's green, and you'll also notice that we have a server associated to it. So within this data center here, you can kind of see here is the data center that was created. So this is really important that you create the data center first. Most likely you will have an existing data center already. The next step is to create the server. The server is really important because the server has multiple steps, multiple processes. So you create the server, you give the server a name. The eDNS CRD is going to refer to this. That's why it's really important. CIS needs this in the CRD to refer to the service, so it can associate the pool. So here is the name, Big IP-60. That's Big IP 60. The Big IP here, Big IP 60. So that's just what I called it. And this is the product. That's Big IP system. There is the data center. I'm going to inherit all the information from the data center with regards to the probe preference. The state is enabled. So once that first piece, then you create the second piece. The second piece is the self IP where GTM is coming from. This is really important. This preferably needs to be an external self IP. And so in my case, I am using the external self IP that I connect to the Big IP externally, not necessarily internally, because my Big IP has an external interface and an internal interface. So Kubernetes is the internal side. I connect to it on the external side. So this is what I've done. I've given it the external IP address of 75.60. That's the same IP address that I connect to over the web UI, which is actually not the management port, it's the external IP address that I'm using here. And so that's my external address. I set the health monitor to Big IP itself, so DNS is going to pull the information out of Big IP. And of course, most important, virtual server discovery has to be enabled. This is currently something that is a requirement. Virtual server discovery has to be enabled. We're potentially going to look at removing this later on, but as of now, it's very important, must be enabled for the solution to work. So now that we have created the server, you can actually see the server here. And so there is the Big IP-60 cluster. You can see that there's no virtual IPs at this point. As you can see, the virtual server shows 0. So there's no virtual servers at this point. Here is my Big IP that I showed you before. From that perspective, here is the device itself. You can see the device that I created. This was the device in the second step. I created this device. And the third would be the virtual server, which there's nothing. So this next step would obviously be, once you've created your data center, once you've created your server, to actually go and create your virtual servers. So your virtual server is a standard CRD virtual server. We could actually look to see what it looks like by clicking this repo here. If we wanted to see what that CRD looks like, we can go into my site here and actually click on this. It's a very standard virtual server. That host name, mysite.f5demo.com, is important. We're using that virtual IP address. That's going to be the A record, that virtual IP. So this is for LTMP. So let's go and create these two. And so we'll see where we are right here. So we'll go and create this one right here. CTL create -f, and this is vs-my app, and we'll change to my site, kubectl create -f vs my site. Okay, so now we've created the two. You can actually see the declaration. You can actually see there is the two declarations that are actually going. And so if we go back to the Big IP, first of all, go to LTM, change to the tenant. We can see there are the two virtual servers, and we can actually check the pools. They're using the same pool, it's shared pool. So they're both using the same pool. We can connect to it, my app. So there is my app, and there is my site. So the virtual IP is working. So we have the local, we have LTM configured. Now if we go back to the DNS piece and take a look at the DNS piece here, there's no wide IPs. But if we go down to the servers, we should see two virtual servers, and they are both green. So what happened here is DNS discovered the virtuals through virtual server discovery. That's really important. As it discovered these virtuals, we can now then go, and we know that the data center is working. We know that the server is set up correctly. We can discover the virtuals. We also know that LTM is configured correctly. LTM can monitor those endpoints. LTM can ultimately monitor the pods. Since we're using cluster IP, VXLAN, we can monitor those pods, and we can communicate with the pod directly. There's no proxy end path here. It's Big IP to pod. So the next step, the final step, is to create the wide IP. This is the last step. Let's go back to the user guide. And so in the user guide, we tested and validated that. And now what we do is we want to create the wide IP. So very important. The host name in the virtual server needs to match the domain name in the CRD EDNS as well as the pool name. So let's take a look. So we saw here, this is for my site. There's my host name, mysite.f5demo.com. This needs to match the external DNS, as you can see right here. It's external, make it a bit bigger. So as you can see here, kind external DNS, this is just a name. This is true, means it's enabled. So there is the domain name. So mysite.f5demo.com, and there is the pool name mysite.f5demo.com, and this is the monitor. So this is the monitor that will get configured on DNS to monitor the virtual IP and to send this host, right? Because a host is required based on the application. That is the name of the data center server name. So required. Domain needs to match. Domain name needs to match. Pool name needs to match. The monitor needs to be 100% correct, or else you're not going to be able to get a successful DNS probe. And the data server name, the data center server name, needs to match. So there's quite a few things here. Quite a few things need to line up. But once you get these two lined up, you're going to be successful. So let's go and take a look back here. There's no wide IPs. So let's go create these wide IPs. So we are in my site. So kubectl create, and that's a eDNS for my site. There is that one. And we're going to change to my app. And we're going to go kubectl create -f. And that's eDNS for my app. And so there are those two. You could actually see there's some API. There's no changes on the API from LTM side, but there is some changes for on the GTM side, but no changes on the LTM side. So as you select right now, bam, you can see that they're there. These are the wide IPs. So this is what you will be configured to point to when you're doing your wide IP. So your wide IP is really cool. So let's take a look at my site, for example, here. Now, because we only have one site, we're only going to have one pool. But the next demo, mysite.f5demo.com is going to have multiple pools because there's going to be multiple clusters, multiple locations. So as you can see here, this is just the pool name right here, which is just one pool. But my goal is to create multiple here. And then this is obviously the round robin here. You can see this goes back to this specific location, which points back to this member, right? Which points back to the system right here. So if we go back out, take a look at the pool list, you can see that that these are enabled. And of course, there's one pool member here, and these are specific A records. And this is kind of where they live, and that's the physical IP address for that one. So there'll be a different IP address, obviously for the other one, and I'll point my NS record kind of like to the big IP. So DNS, and then I need to enable the DNS to answer or be a listener for DNS. That's a little bit outside of this video, but I just want to kind of show you how cool this is. So to recap, what we've done in this demo is we created a CRD in Kubernetes for the virtual IP on the big IP, right? Within regards to LTM, which is our load balancer. And then what we also did is we created an external DNS or eDNS entry for the DNS or the GTM function, which takes care of the global server load balancing. So we have global server load balancing as well as local load balancing for this Kubernetes cluster. And so this is how you can really create global server load balancing within Kubernetes using external DNS to provide global server load balancing for all sorts of cool reasons. Hope you enjoy this. If you like this video, like, subscribe to this channel, provide me feedback, tell me what other videos you'd like to see. You can open issues, you can kind of reach out to me. If you're having trouble or challenges, I'd recommend opening a issue on the F5 Networks GitHub page for our platform and product. This is fully supported. So let's go to the GitHub repo. And so this is covered under F5 networks. And CIS is right here. And so you can open an issue right here. You can open as many issues as you want. This code is fully supported. If you need help, open an issue here. One of us will help you. We've got a full dev team that supports this. And if you want to see more videos, then provide me some feedback. You can provide that feedback in this other repo here, or just send me a message on YouTube.